Hello everybody, my name is Ferdinand Gerhardus and I'm one of the business development managers from Anritsu in EMEA. Here today I'm proud to give you a quick insight into the capabilities of MT2780, also called IQ Fiber Master. We will give you first a short introduction into the product, and then we are running an offline demonstration that is based on captured IQ data of a real site. So first of all, what is the IQ Fiber Master? And as I said, then we are talking about a demonstration of some real capabilities. So PIM, also called passive intermodulation. PIM has severe impacts upon the performance of cellular networks, and the operators are having a burden, and they are talking quite often about the cost of PIM. PIM is influencing negatively the OPEX of networks due to multiple site visits, customer churn rates, tower climbings, and as a figure of thumb you can say that any kind of 1 dB degradation due to PIM is causing around 10% coverage loss, or even a 9 dB reduction due to PIM is causing 60% reduction in high-speed service and coverage area. So it's a self-understanding that throughput in the cell, latency behavior, number of dropped calls or rejected calls, and the accessibility in general is negatively impacted. So what is now the IQ Fiber Master? Before we are answering this, let's just quickly review what we had so far in the portfolio. So far, the Anritsu BTS Master MT2780A was the choice of all in order to try to detect and measure PIM via the CPRI interface. 2x2, 2x4 MIMO, all this was possible. Compatibility to Nokia Alu, Samsung, one uplink and one downlink fiber. But what was lacking finally is the capability of really replaying CPRI data, the capability of distance to PIM in order to find out where is the root cause in the system or in front of the system, and no way of PIM monitoring or PIM long-term analysis and monitoring. And the new IQ Fiber Master changed this dramatically. So the new IQ Fiber Master is nothing else than a very small box that has here 4 slots for 4 SFPs. This means you can check the PIM behavior of 2 different systems underneath each other. And this is also one of the very big differences. So it is an all-in-one CPRI-based RF and PIM analyzer that allows you to monitor and to measure the RF spectrum, but based on the CPRI interface. It allows you PIM analysis according to the level of the PIM and the distance to PIM. And it offers you the capability for PIM analytics, also called PIM monitoring, and the user is getting some kind of PIM heat map and intermittent PIM behavior over day, time, night behaviors, and so on. And all this can be done with 3 different inputs, whereby 1 uplink is measured regarding what are these 3 different downlink signals are creating PIM-wise in this uplink band. So this PIM analysis is done during real site operation. It is non-invasive. This means the site remains operational and it's accurate because it relies on real-world testing. The IQ Fiber Master is supporting all LTE bands in one sensor. All network equipment manufacturers are supported. Line rates from 1 to 8 are supported, and up to 4x4 MIMO support. There is no certification required to operate the IQ Fiber Master, because compared to the PIM analysis of the past, there is no active radiation of electromagnetic signals. And the small box is very compact, just 4.5 kilo, that's all. So, what is now the concept? How it's working? Let us assume a typical site with remote radio heads in each sector, as we see it here. Then the IQ Fiber Master is becoming the man in the middle. Beside the IQ Fiber Master, there's an IQ tapper, and this IQ tapper is tapping out some CPRI light energy on the interface, and this signal is then analyzed by the IQ Fiber Master. So it is an all-in-all PIM detection, reporting, and monitoring solution. You can use any kind of i7 grade laptop, tablet PC, or other PC architecture in order to run the IQ Fiber Master program. And it is compliant to all the LTE bands that are existing on the world, not as we are saying here in Germany. Sorry, the production of this video happened in Germany, and that's why we are seeing here the typical bands. But band 1, 3, and so on, and band 20 are the typical LTE bands that we're seeing across the globe. So, thank you very much. Now we are going into the details. Now we would like to show you, based on recorded CPRI data, how the different functions of the IQ Fiber Master are working and performing. Yeah, here we go again. So once you have started the IQ Fiber Master software, you will see this graphical user interface over here. And in order to investigate this offline capabilities, you have to set, first of all, the license and to correct pass into the directory for the previously recorded IQ data. So let's start here with file and licensing. So you have to type in here your license key that you have received from your Anritsu representative. And then you see that this license key enables you to play a little bit with option 752, that is the CPRI out of interface, 754, that it's PIM analysis and distance to PIM, and 755, that is PIM analytics or PIM monitoring. So next what you have to do is you have to set here the test vectors directory, and your Anritsu representative may have provided you with a so-called demo repro folder, and in this folder are all the IQ recordings that we are using here for our offline demonstration. So once this is done, we can play a little bit with our baby here and test the capabilities. So in general, the IQ Fiber Master has two main tabs. Tab number one is here the site editor, where you are defining the site parameters. Tab number two is the test roster editor. Here you are defining the different test cases that you would like to run later on. And then we have tab number three, where you are running really the tests later on and attaching the test reports, the test results, sorry, into a test report. So let's start with the site editor. Let's go to new to get rid of the past. And usually, if you are on site, you are not pretty sure what kind of line rates you have, what kind of SFPs on the optical interface you have. And that's why it is very convenient to have this kind of auto-detect functionality that takes a lot of burden from you in finding out all the parameters. But what you have to do is, first of all, you have to connect to your sensor. So leave this tab here under sensor emulation and go to connect, and you will see here in the bottom that you are connected to the local host and that all this loss of signal, loss of fiber, CPRI interface, everything is okay. For sure, if you are starting from scratch, you should know how many systems you have on air. In our case here, we have per sector 2 remote radio heads, and one of these radio heads is working on frequency A, and the other one is working on frequency B, let me call it like this. So in total, you have here 4 system fibers. And you have 1 fiber for the uplink of system 1, 1 for the downlink for system 1, 1 for the uplink of system 2, and 1 for the downlink of system 2. And for sure, you have to decide before you're going to auto test what kind of network equipment manufacturer vendor you may have here on the line. In our case of the offline demonstration, leave it here to custom. And we have also here a single mode side. So if you're going now to auto detect, something will happen. You may have seen here some reactions in the tray. And when you are scrolling here now down, you will find out that SFP1 has detected an uplink with line rate 3 and 1 carrier. And it's an LTE 10 MHz signal that has information in the so-called AXC, also called antenna container 1 and 5. We have here the downlink also in 1 and 5. And system number 2 is also an LTE 10 MHz system, but it has 4 carriers in 4 different antenna containers. So far so good. So what you are doing next is, we would like to map all these optical parameters into RF parameters. So we are going here to the right side, and we know we have 2 systems. That's why are we enabling here 2 systems. We are going here to this plus, and now you see that is here in our case band 14, a downlink frequency and uplink frequency. And what we are now doing is we are dragging from the left side, from the optical side, the information about the antenna containers to the right side into the RF section. So we are highlighting here, for example, antenna container 1 and dragging this here to the right with antenna container 5. So both uplinks are done. We are doing the same for downlink. Okay. We are doing here the same. Then we go back, enlarge the second system. And we are doing here the same for uplink 1, 2, 3, 4, and we're doing the same for the downlink frequencies. Okay, that was an easy task. And now we have also the possibility to get a quick impression if everything is okay. And if we are clicking here on this auto detect spectrum, you see here all the relevant information on the SFPs from the relevant antenna containers. And you can see here in purple some kind of downlink LTE signal, and you see here a couple of uplink LTE signals. So this auto detect feature is running quite well. That was the first part of our offline demo. Thank you. Yeah, we remember that the auto detect feature here was able to detect all SFPs and the optical parameters. And what we are doing now is we are switching into a mode where we are just replaying previously recorded IQ data from a real site. We have now loaded here our test site A1234. We have also generated here some test cases. And if we are now clicking here on CPRI analysis, we are seeing here some very interesting traces. So what we are seeing here on the top in red and in gray is a typical downlink LTE signal. And what we are seeing here at the bottom in orange and green are uplink traces. And we would like to make this CPRI spectrum analyzer, finally it is exactly this, a little bit more nice. So we are going to settings. We would like to arrange the traces in a way that we have the downlink traces separate from the uplink traces. So we have created now here two different windows. We're going to plots, and on plot number 1 we would like to set just the downlink frequencies, 763 megahertz, and we are getting rid of the noise, the traces where nothing is in. That is the blue one, and that is the green one. So that is quite nice. And then we are switching over to plot 2, and on plot 2 we would like to present just the uplink frequencies of SFP1, and here we are deleting also the purple and the blue trace. So now we have here in a split screen representation on the top the downlink, and in the below on the uplink. And we would like to adjust a little bit here the scaling. For the uplink we are enlarging this. We are going to we are going to access. So we are making this here a little bit nicer. So, and we see here now on trace 1 uplink of antenna 1, and we are seeing on trace 2 the uplink trace of antenna 2. And what we can assume here immediately is that the uplink behavior of trace 1 is above trace 2, so there might be some additional noise on. And what we can do is we are going here to average, you see, and we would like to average this also. And then we are seeing the typical sharp pin as a Pim as we're seeing it here. This is a clear indication that we will have some Pim contribution on antenna 1, and the Pim analyzer in the next step will give us a proof exactly for this. So with this so-called CPRI analysis functionality, you have here more or less a real spectrum analyzer with any kind of feature that you may think about, different traces, different markers, and so on. So finally, what you can do here with this CPRI analyzer is that you can replay also own captured IQ data. Okay, what we are seeing here now is already a replay of IQ captured data, but let us assume this is live what you are seeing, and for reasons of comparison you would like to load some other CPRI IQ data that you have gained beforehand. To do so, you're going to playback. You are going to load playback. You are switching to the correct folder, and I am replaying here some files that we have gained in Prague. You are opening this file and you are just going here to enable playback. And you can easily see that the traces and the trace behavior has changed. We see here again 2 downlink carriers. We see here again 2 uplink carriers. We may assume here again some PIM contribution, but not that severe as we have seen before. And you can go back here, switch to live, and then you see again the live traces. Okay, so although this is working, so finally the CPRI analyzer is nothing else than a spectrum analyzer with all the features that you can think about, but just on baseband signal, just based on the CPRI data out of the several antenna containers. So, thank you. That was the insight into the CPRI analysis features. Yeah, welcome back. So after we have demonstrated the auto-detect feature of the IQ Fiber Master, we would like to penetrate now really our previously IQ recorded band 14 and band 17 site. In other words, we would like to load existing site information, we would like to load existing roster test information, and then we would like to run a general CPRI test, a PIM test, a distance to PIM test, and so on and so on. So let's go here to new. We are now loading an existing site configuration. Go to load, IQ Fiber Master, and now be aware you must click into this demo repro folder, and we are selecting the site AA1234. Open, and we go here to apply, and what we see here, we have again SFP1, SFP2 for an uplink and a downlink, and another SFP1, SFP2 for another system in uplink and downlink. You see here, these are the bit widths and the reserve bits and idle bits settings of this. And if we are going here on the RF part again, you see band 14 is similar to what we have had before, defined here with 4 antenna containers, and band 17, band 12, sorry, is defined here with just 2 antenna containers. So this is our site information, and this was the condensed view. And if you were going here to the so-called advanced view, because this is a huge XML file, you see here all these details. PIM forensics demo site, site latitude, site longitude, and usually you can edit here all the parameters, and by saving and loading it again and so on. So let's leave it here as it is. Now we are going to tab number 2, that is a test roster editor. And if we are going here, for example, to auto-generate, the roster is creating any kind of possible combination that we could test in theory. And remember what we have here. We have here 2 downlinks, and we would like to investigate the influence of this combined 2 downlinks on a specific uplink. So we have here the capability of testing band 14 just on band 14 uplink, band 14 and band 17, regarding band 14 uplink, or band 17 and band 14 regarding band 17 uplink, and so on and so on. So this can be for sure a long list, and now be aware we are doing this sector by sector. So to keep it a little bit easy here for the course of our demonstration, again, we are loading some predefined settings. Yeah, the test roster has been changed. Do you wish to continue? Yes, we would like to wish to continue. So, and then we are loading again our site information. Yes. And we are loading also from the demo repro again the test roster information. And what we are seeing here is we made it simple. We have just 3 defined test cases. We have 1 test case for sector 1, meaning alpha sector, 1 test case for sector 2 beta, and 1 for sector 3 gamma. And what we would like to test all the time is how is band 17 and band 14 downlink influencing the uplink behavior of band 17. And beforehand, the operator has decided that the limit for any kind of decision is around minus 102 dBm, and he is willing to accept the desensitization of 3 dB in the uplink. And we are testing all the time antenna 1 and antenna 2. And what we cannot do here in the offline demo, the cross-coupling of the sectors, but we would like to test PIM level, distance to PIM, and what is the noise rise behavior. So again, we are going here to apply. That's all. Now we are going to tab number 3. This is run tests. And here, first of all, we have to select one of our test cases, and we would like to start with test ID number 1. And we are starting all the time with a so-called configuration check. So this config check, I'm clicking to this, is testing again all these optical components. And when I'm clicking here add to report, then we are seeing here the content. You see here that SFP1 passed, CPRI connectivity passed, IQ capturing capability passed, the antenna containers of the several bands passed, and so on, and so on, and so on, and so on, until to the end of the list. And here we see something in red, means not calibrated. For sure, we have here not a real remote radio head, and this means in the course of this offline demonstration, we cannot calibrate the noise floor of a real remote radio head. So we are assumed that we did it already once we captured the IQ data, and that's why we don't take care for this here at the moment. So we are closing the report. And next, we are clicking here on PIM level. And then we are just running the PIM level test. And here you see now uplink on 709 MHz antenna 1, uplink 709 MHz on antenna 2. And when you're looking here to the tray on the bottom right, you see that now our IQ data are here replayed again and again, and that the fancy mathematics is trying to calculate the desensitization in order to find out if there is some PIM or not. Yeah, and we are getting here the first result in red saying antenna 1 is failing, having a PIM level of around minus 98 dBm and an RX desensitization of around 6 decibels. And the PIM source location is expected to be external. External means, in our case here, it is before the radiating antenna, somewhat over the air, a couple of 10 or a couple of 100 meters or so on in front of your antenna. And we have now also the second result here saying antenna 2 is passing, no desensitization, no PIM has been detected, so it remains in green over here. Okay. What we can do next is we are clicking on the Analyzer tab, and on the Analyzer tab we can click here on selecting antenna 1 or selecting on antenna 2, and when we have clicked the antenna 1, we are seeing here in green the uplink traffic, and we are seeing here in orange the PIM behavior. And if you're really looking to this, you can imagine here this slope. We call it also PIM fin shark, and that gives you a good indication that this PIM is really existing on site, and the difference, what you can see here, is the desensitization. And on antenna 2, you see it is less pronounced, and the orange trace is much more below the green trace, and according to the limits that we have set before, there is no PIM detected. If we are clicking now to PIM versus time, you see here, first of all, on the x-axis, the hours of the day. You see here in red, that was the threshold that we have defined beforehand. And we see here in green the results of antenna 1, and in orange the results of antenna 2. And we are seeing here the first results of antenna 1 and here of antenna 2. And what is here in the red area is for sure critical. That's why it is here highlighted with a glooming red behavior. And what you can see here is the maximum detected PIM, the minimum detected PIM, the mean average, and also when the maximum did occur. So let's now imagine that this is running now not only for a couple of minutes, it's running for a day, it's running for a week, and you are recording all this. And then you are getting a behavior of the passive intermodulation over the day, over the business hours, in the morning, in the afternoon, and so on. And clicking here to Pim Distribution, it's just another representation. In the red line is again our threshold. And you see here the percentage of the PIM values. That is more or less some kind of histogram telling you how the distribution of the PIM in percent was over the levels. And if we are clicking here to PIM daily, you see we started at around 4 o'clock in the afternoon, started at, lasted at, and here you see again the antenna 1 levels of antenna 1 and also of antenna 2. So here you see the hourly PIM level measurement failure rate. So let's go back to run test, and we stop this here, and we would like to add this to our report. Yeah, you see, just by adding this to the report, you have now, beside the first amendment of the report, all this measurement results here again attached to the report. And we are coming to this here later on in the next course. You see, everything that is useful to know is now included in the report. So let's close the report again. So what we are doing next is we would like to detect the PIM location. And we are clicking here on Pim Location, and we are running the Pim Location Test. And what you are seeing here now on the screen is this typical distance to PIM chart, where you see meters on the x-axis and power on the y-axis. And this can take you now up to a minute until any kind of figures are displayed here. But be aware, what we are seeing here is an uncalibrated measurement. So the question is, how can you calibrate really such a distance to PIM chart? First of all, you have to find out where is physically the transition from the system onto the air. This means where is the radome of your antenna? And you are doing this by attaching a piece of steel wool or a bunch of keys or the Anritsu PIM generating pad onto the top of the antenna, then the network operator is powering up all resource blocks of the LTE signal, and then you are getting for sure, as we are seeing here, a very pronounced PIM peak. And you know, hey guys, this is now here my antenna. Everything that is here on the left side, meaning this is inside our system, and everything what is here on the right side is over the air, is in front of my antenna. So what you are doing then next is you are removing your steel wool or the Anritsu PIM generating pad, and you are redoing the PIM test again, and then hopefully you will see here a difference between the previously peak and when the new peak is here on the right side. This means so and so many meters your PIM source is in front of the antenna, and when it is here on the left side, you are aware after how many meters on the coaxial line the PIM problem will exist. Okay, and you can do this here again for antenna 1, for antenna 2, and so on. So let me come back here to the heat map topic that I mentioned very short beforehand. So clicking here on the heat map, you will see here an easy to understand visualization what happens on site. You see here on the left side the downlink frequencies, you see here the uplink frequencies, and here in our particular case you see that the combination of antenna 1 uplink frequency together with 739 megahertz antenna 1 downlink frequency might be here the case for a problem. The same here and the same there. And on top of this, you can read here really a heat map summary saying PIM is likely to be external on uplink 709 megahertz on antenna 1 and no PIM found on uplink 709 megahertz on antenna 2. And to make it easy to read and understand, we have attached here some typical results where all antennas are hot, or one antenna hot from each band, or a mix of hotter and cooler antennas, and so on. So this may happen in reality, and this is an easy to understand interpretation of the PIM situation here on site. So let's go here to stop. Let's add this again to our report. Let's close our report. So finally, let me come back to PIM versus time. Here you have for sure also the possibility to load historical data. This means PIM data that you have gained before in order to reanalyze them or just simply to watch them. So you're going here to load file. You're going now on the demo repro, the live folder, and in our case test 1 monitor. Save results. Test. Okay. And what you see here now is the behavior of the site on April 17th, April 18th, 19th, and so on during the relevant hours over the day. And you can click here to dedicated days, or you can click here to a summary. So finally, this gives you also a very good overview about how the PIM behavior was over a longer period of time. And that's why we are talking here about PIM analytics or PIM monitoring. So finally, we are saving our report. Test, demo, report. And now you have every kind of measurement result in a very comprehensive, easy to read and understand report. The customer can equip the report with own logos, with own headlines, and so on. Okay. Thank you. This was then finally the test for Pim versus time and heat map.